Hi, welcome to Gourd Tech. It's been a while, but we're back with a lot of new things, including this brand new guitar pedal studio. Let me show you around. Over here we've got our testing station. We've got all of our components, soldering station. Right here we've got permanent basement decoration, another permanent basement decoration. Over here we've got our infinite water source. See, it's making water right now. Let me take you to the other side. So over here we have our screen printing station. Blur all this out. They don't need to see this right now. If you follow me over here, we've got our slot sink. This painting of these bears. It's very nice. So yeah, that's what we have.
We're back, and I've been wanting to make a suboctave fuzz for a while now, so let's do that. To start with, I put together this 3-transistor fuzz circuit, pretty much working as a bass fuzz running into a fuzz face. I'm using this circuit to get us as close to a square wave as possible without doing anything too complicated. The reason I want a clear square wave pulse is to drive the heart of our circuit, this CD4024 clock divider chip. How this chip works is it counts the pulses going into it and divides them. So for every 2 pulses, a pin dividing the signal by 2 would send out 1 pulse. Here I have some LEDs set up to the chip, where the original signal has to blink 16 times before the final LED finishes a blink. We can use this same setup to make an octave down. For every 2 pulses the chip detects from our audio, it'll send out 1, making a signal that's exactly an octave lower. Here's what that sounds like plugged into our fuzz circuit. Now that actually sounds pretty terrible. The reason being is that this chip needs a certain input to work properly. That's why I tried to get the fuzz circuit as close to a square wave as possible. Because if this thing gets any kind of harmonics, it doesn't know what to do and just starts throwing out noise. For this circuit to work, we need a clear, loud pulse. Unfortunately, right now, background noise and some harmonics that still exist are making this thing go crazy. Not really detecting our signal and sending out a constant high-pitched squeal. To fix this, we can add some filtering going into the chip. I have to say that I pretty much just took this part from the Bit Commander. I tried to have an original thought here, but nothing I tried worked as well as this combination of capacitor and resistor values. So thank you, Earthquaker Devices. With this filter in place, here's what the circuit sounds like. Now we have an octave down. And this is pretty much the idea of any analog suboctave circuit, a signal driving a divider. From here, a lot of pedals add filtering and modulation to get different tones, but I'm not going to do that. I like how this sounds. So now that we have this circuit working, let's try the other octaves we can get from this chip. Here's our standard bass octave.
Here's 1 octave down.
Now we could go lower, but we really don't need to, since at this point it just sounds like clicking noises. Really, the first 2 octaves are the only ones that sound usable, so let's add those 2 and our bass fuzz sound to a mixer circuit with an output buffer. Here's what all 3 octaves mixed together sound like. I I love this big synthy octave sound. From here we could just box this circuit up and put it in a pedal, but there's one more thing I want to try. The second octave down is low enough that it could almost go into LFO territory. What if instead of mixing it with the other octaves, we had it control their volume like a tremolo? I decided to try that and put together this circuit. Here's what it sounds like. You can still make out the second octave in this version, but since it's being cut from the other two instead of being added, it's less full sounding. It almost sounds dry, like a desert bone. Let's add a switch to the final pedal that lets us change from mixed mode to this version. From here I'm going to screen print some artwork my brother made, calling this pedal the ground beef, because of how low it is. After doing a point-to-point build of the circuit, here's what it looks like. And here's what it sounds like. This pedal really has a sound that you need to commit to if you're going to use. It's glitchy and barely sounds like a guitar, but if you use it to its strengths, you can get the sound of a square wave synthesizer with the nuance of guitar playing that you can't get on a keyboard. Let's try using it in a jam. Thank you for watching this video. If you want to be the owner of this one-of-a-kind ground beef pedal, check it out on our Reverb store, link in the description. And be sure to keep on checking out our channel because we are back.